Okay, so I'm intrigued by this problem. I'm going to go ahead and solve it with you. It's number 42. A person accidentally swallows a drop of liquid nitrogen, which has a density equal to liquid oxygen, 1.149 grams per milliliter. And assuming the drop has a volume equal to 0.050 milliliters, what volume of gas will be produced in the person's stomach at the temperature 37 degrees Celsius, which is going to be 7 plus 3 is 80, 310 Kelvin, and a pressure of 1 atmosphere. Okay, so we have a P, a V, a T, and we have an R, and all we need is an N. And so we're going to use this density and find our N. So, let's see, we know our volume and we know a density, so we can find the mass. So we have density equals mass divided by volume. So, density times volume equals mass. So we have 1.149 grams per milliliter times 0.050 milliliters equals my grams of oxygen. And I can actually go from grams of oxygen, and I know that there's 16 grams of O and 1 mole of O, but this is actually O2, so I'm actually going to use 32 grams of O2, and 1 mole. And so what I'm going to find here is that the moles of oxygen is 1.8 times 10 to the negative third moles. So now I'm just going to use PV equals nRT, and what we're going to find is volume equals nRT over P, and that's going to equal 4.6 times 10 to the negative second liters. So the tricky thing to do in this problem was to figure out that we needed to use this volume twice, once in PV equals nRT, and once for the density. Some of you might have actually rearranged this equation to include density, and that is also a way that you could solve this problem. But thanks.